So in section 4 we're talking about radians and degree measure. So here we have our circle, and we start dealing with radians, and we know in a radian A is going to equal B. B is our arc length and A is our radius. So from there we can extract our formula. Radian equals arc length over radius, and therefore we can also write as arc length equals radians times radius. We have an example over here. Imagine that our arc length is 10 and our radius is 5. We just have to plug the numbers from our formula. So radian equals 10 over 5. Our radian will equal, our value will be 2 radians. Then we talked about complementary angles and supplementary angles. Complementary angles are all of them that add to 90 degrees, and supplementary angles are the ones that add to 180, 90 degrees or pi over 2 or 80 degrees or pi. An example of it, imagine they give us one angle that is 40 degrees, and they ask us to find the second angle, so we just have to use our complementary angle idea that adds to 90, and we use it by subtracting 40, and that would give us the second angle. In this case would be 50, since 50 plus 40 would be 90 degrees. Then we convert degrees and radians. We can do from radians to degrees or vice versa. For example, to degrees to radians, we just have to use this idea of pi radians over 180 degrees. And the other way is they give us pi measuring radians, and if we want to convert it to degrees, we just have to use the idea of 180 degrees over pi radians, since these will cancel and this one over here will cancel too. For linear and angular speed, in our linear speed would equal our value in radians times the radius over time, and angular speed would be just radians over time. So the answer here would be measured in inches or centimeters over time, and here radians over time. An example, for instance, they give us the radius equals 5, our revolution is 60 seconds, and in a radian of 4, which is the linear speed of the whole thing. So we just have to plug the numbers: 4 for radians, 5 for radius over 60, that's our time. It would be 1/3 inches per second. Then after this, we get into trigonometry. We always have to remember this to make it easier. So SOHCAHTOA for sine, cosine, and tangent. We know for sine of theta, it's opposite over hypotenuse. For cosine of theta is adjacent over hypotenuse, and for tangent is opposite over adjacent. And then cosecant, secant of cotangent are the inverses of this one. Cosecant is inverse of sine, secant is inverse of cosine, cotangent is inverse of tangent.
And I'm just going to make a quick correction that reciprocal is not inverses.
Yeah, reciprocal, sorry. And an example here of a basic triangle. Sine would be 3 over 5, cosine would be 4 over 5, tangent would be 3 over 4, and then the other 3 would be the inverses of the one they said. And then graphing trig functions. We can describe a function as y equals a trig b parentheses x minus c parentheses plus d, where a would be our vertical stretch, b would be our horizontal stretch, c would be when it moves left or right, and d would be up or down. These are the basics, the basic graphs. Cosine starting at 1, sine starting at 0, then tangent right here, where we have asymptotes where our cosine graph would equal 0, here, 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 here. Cosecant, where our sine graph would equal 0, at 0, pi over 2. And then secant, we have to look at cosine graph to describe it. They have in common 1, 1, 1 over here. So, and then cotangent is the opposite of the inverse. Not the opposite of tangent. Yeah, that's it.
Alright, so over here we have the unit circle. So the way the unit circle is x and y also equals cosine and sine. So when you want to find a point, well, you want to find when you have a degree and they ask you for a point, so it will be cosine of 30 degrees, which is square root of 3 over 2, and sine of 30 degrees or pi over 6 is a half. And so this is the point, square root of 3 over 2 and 1 over 2, which is also x and y. So, and it goes for any angle. So if they give you, for example, 120, so you do cosine of 120 and sine of 120, and that's going to be your x and y. For trig function of any angles, so we have, these are the identities of sine of theta equals y over r, cosine of theta equals x over r, tan of theta equals y over x. And for cosecant, secant, and cotangent, it's the reciprocal of sine. Cosine is secant, tangent is cotangent. And over here we have kind of like the basic model of it. So when they give you a angle, this the line will be your radian, and then the point x and y. So for example, this is an example. So if they give you the point -3 and 4, and then they ask you to find any of these 6 trig function, we find r by doing the Pythagorean theory. If x is -3 on this side and y is 4 going up, and to find your radius, you do the what's that equation?
A squared plus B squared.
Yeah, a squared plus b squared equals c squared, which is -3 squared plus 4 squared equals c squared, and then equals 5, ends up being 5. So, and then the way you figure out each of these, you just plug in the values. Simple. And then, oh yeah, one more thing. Y can't equal 0 on this side for secant. X can't equal 0. Y can't equal 0, and for tangent, x can't equal 0, because that would be undefined, and it wouldn't make sense. For reference angle, pretty much the basic. They give you an angle, and the closest to the x-axis, you kind of subtract by, for example, 150. They give you the angle 150, so 180 minus 150 equals 30. So this is pretty much how you get your reference angle. Does that make sense? Alright, cool. And so now we have some of chapter 5.
This one over here is solving trig function equations. So there are a lot of problems that will give us, they will want us to solve for x. So I just did a pretty clear example. We know sine of x equals 1 over 2 at pi over 6 and 5 pi over 6 in our unit circle. So we know that x can equal pi over 6 plus 2 and pi. That means like it has to go a complete revolution. For example, pi over 6 will be over here, and 5 pi over 6 will be over here. This x is an x here. So we know that at pi over 6 it will do a whole revolution. That's why we write 2 and pi. And 5 pi over 6 also has to do a complete revolution to come back to the same place. And then sum and difference formulas. We know that sine a plus b is going to be sine of a cosine b plus sine of b cosine a. If it was subtraction, we just have to change the sign to negative over here. And then for cosine, if it is cosine a plus b, we know that cosine of a cosine of b minus sine of a sine b. And if it was a subtraction, we just have to change the sign to positive. And then tangent a plus b would be tangent a times tangent b, no plus tangent b, over 1 minus tangent A tangent B, and if it was subtraction, we just have to change this sign to negative and this sign to positive. And then for multi-angles, we know by a proof that sine of 2x the same as writing as 2 sine x cosine x. Cosine of 2x equals cosine squared x minus sine square of x, and tangent of 2x equals 2 tangent x minus tangent square x. And then we can use these formulas over here to also solve trig equations.
Alright, so over here we have using your fundamental identities, and why we use them is to verify that proving that identities. So we use these identities to prove, for example, if we have if we have an example, like if we want to prove cosecant squared of theta minus 1 over cosecant squared of theta equals cosine squared of theta, then we use some of the identities over on this side to figure it out. And our first step is, and there's no really step to kind of figure it out something. There's no kind of fast, so you kind of try some of these to see if it works. So yeah, so over here, so our first step is I would do cosecant squared of theta minus 1 over cosecant squared of theta, which is the same thing. I'm just writing it in two different sides. And as we can see, this cancel out to 1. It's going to be 1 minus 1 over cosecant squared of theta. And we know that 1 over cosecant squared is also sine of x. So 1 minus sine of x, sine squared of x. And then since we know 1 minus sine squared of x also equals cosine squared, because of our Pythagorean identities, we have it right here. If you subtract sine squared of x, it equals cosine squared, which is our answer. Ooh, theta, not x. And we have our answer right here by using these identities.